Welcome to the Taipei Ethereum event. I'm delighted to be here. I'm delighted to see you here. I'm gonna start by giving you a little introduction of the speaker today. Today we have a very special guest. Pleased to welcome Cayman Nava to our meetup. I met Cayman at ECC, the Ethereum Community Conference, in March this year in Paris, France. Cayman is a technical lead on the Lodestar project. Lodestar is an Eth2 client written in TypeScript. It's essentially a TypeScript implementation of the Ethereum 2.0 specification, and it is developed by ChainSafe Systems. So ChainSafe Systems is a Toronto-based blockchain research and development firm contributing to Ethereum 2.0. So most of the team members, I think, are based in Toronto, Canada, but Cayman is currently based in Texas, USA. So we're having this video call right now with some of the folks in Texas, in Toronto, and in Taiwan. So today, Cayman will be giving us like a few demos, introducing several web tools built using Lodestar, and he will be showing how they fit together in the larger Eth2 world. And there will be plenty of time for Q&A. So if you have comments right now or like questions, go ahead and drop us a message or comment right now on the YouTube live stream link. So Cayman, take it away.
Thanks, Phil. Yeah, alrighty. So, welcome everybody. First off, I want to thank the organizers for inviting me. You guys are very gracious, and I'm happy to present the work that we've been doing. So, today I really want to focus on kind of the demo side of things, so I'm going to skip real quick through the slides and so we can get to the fun stuff. So, thank you guys for the introduction. Yeah, I'm technically on Lodestar. You might have seen me on Twitter or GitHub. I'm pretty quiet on Twitter, but I'm very active on GitHub. These are my avatars, so you might see me in either environment. So what we're going to cover today is real quickly what Lodestar is at a high level. We can look at some of the tools that we built really quickly and then jump into a full demo. I want to demo some of these web tools, and if we have time, I want to show a really interesting, fun way of debugging Lodestar and kind of see how that relates to the web. So, really quickly, what is Lodestar? So, Lodestar is a project run by ChainSafe Systems. ChainSafe is a blockchain development firm out of Toronto. We build all sorts of blockchains, usually L1 protocol level. And Lodestar is ChainSafe plus Ethereum, specifically Ethereum 2. So, what is Lodestar? Lodestar is actually a real word. I didn't know this before joining this project, but it's a star that's used as a point of navigational reference, or the guiding star, which is kind of cool. But for us, it's basically an Ethereum 2 TypeScript and assembly script ecosystem. So we're building out a bunch of different tools in TypeScript, which is a typed variant of JavaScript, and assembly script, which is a variant of TypeScript, variant-ish of TypeScript that compiles to WebAssembly. So both of these languages are geared towards the web. They're web native. And so we think it's going to be really important to have tooling and libraries for web developers everywhere to hook into Eth2. Right now we have 23 or more packages, different Legos that can be used individually, different libraries that can be used individually, or that can be combined all together into a full Eth2 beacon chain and validator client. We run our software, or we run our project in a fully community-oriented way. So we have all our discussion in open forums, Discord. All of our work is done on GitHub, and we really invite anyone to participate. We have received a few grants from the Ethereum Foundation, so um, if a lot of our active contributors have ended up joining our team, um, and we pay them, so it's great. We love the work that we do, and we invite anyone who's interested to join us on GitHub, and I will link to the Discord at the end. So this Lodestar ecosystem, I'm just going to flip real quick over to the actual web page here. We have written a bunch of software already. Each of these different rows is a separate library that does one thing and hopefully does it well. We're going to look at some web tools that incorporate one or more of these atomic units, and at the end, we will hopefully look at something that kind of wraps them all together. We have a mono repo set up for our kind of broader full client, and we have a few packages that kind of go along with that. So one of our priorities this year is to show to a broader audience how Lodestar can be used in the web. And so to that end, we've been building small web tools. So we've recently put together this beautiful website called lodestar.chainsafe.io that showcases a few of these tools that we've built. The idea here with these tools is one, to provide some kind of utility, but not only that, it's supposed to really be educational in nature. So these are supposed to be simple websites. It does kind of one thing. You can read the source code. It's all on GitHub. And the idea is to kind of maybe inspire people to give them a live example. So if you're a developer wanting to use some part of Eth2, you can use one of these websites. And my hope today is that by sharing these things, maybe you can get a little more information out of what Eth2 is if you're interested. If you're feeling a little deeper, it might inspire you to think about what other kinds of websites could be made. Because these three are just the beginning. These are just things that we kind of thought up, that we wanted these tools for ourselves, but there are many more that can be built. So first on this list is simpleserialized.com. Simpleserialized is Eth2's serialization and Merkleization format. If you're familiar with Eth1, simpleserialized is like RLP, recursive link prefix, encoding, and also the textary Merkle tries kind of combined. So simpleserialized can do both things. It serializes data and it kind of informs how to Merkleize the data. We built this website to be able to show some of this visually, at least the serialization part, not the Merkleization part. We'll do a quick demo and we'll see how you can use this in practice. Second on the list is blskeygen.com. BLS keys are the keys that are used in Eth2. They're different from Eth1. They have some special properties. In Eth2, we use BLS keys or properties of them to be able to aggregate a bunch of different signatures together. And so it's kind of, we're using it as like a form of data compression. And this BLS keygen website lets you create new keys from scratch. And finally, we have enrviewer.com. So ENRs are Ethereum name records, and these are objects that are shared on the network, and they inform peers how to connect to other peers, and has a few other little pieces of data. We built this site, enrviewer, that can show the contents of these records. They're not human readable, So we're showing them in a human readable way. So without further ado, let's get into some demos. Let's see. So let's close this board here. So let's start at lodestar.chainsafe.io. It's a pretty simple website. We just have these three main apps. You can also get to our documentation page from here. But I'll stick to script. So let's try out simpleserialize.com first. So this is again, this is just a website to serialize and deserialize objects as they are done in the Eth2 environment. And so some of this can be used just to demonstrate what these objects look like, if you're curious. Some of this can be used in practice if you're a developer in Eth2 to be able to decode these otherwise opaque objects. So one thing you can notice here, we have a serialize and a deserialize tab. Let's start here with the serialize tab. We can see on this list all of the different data types that exist in Eth2, the consensus level. Everything from public keys to blocks and state, network objects that are sent over the network. Everything is really in this list. So let's pick something like status. Status is a message that's sent over the network to inform peers of your status. So what you can do on this website is you can serialize, big green button, bam. And over on the right here, we have our serialized data. This might be interesting if you're maybe debugging your own client or you write your own tools for serializing. You want to check again, you want to check what the result should be. Well, you can do this in the web very simply with this website. Now, on the deserialized side, this is where things will probably be more interesting from a debugging perspective. I want to kind of connect this to things that are going on right now. We have the Eth2 testnets repo here. And this is just a repo that a bunch of the Eth2 client teams are using to coordinate different data. So we can look at this Altona directory. And if you're not keeping up with Eth2 news, Altona is the most recent dev testnet that's running right now. And hopefully things go well in this testnet, we can move to a bigger public testnet. But this is these are some of the really important pieces that you would need as a client in order to join the testnet. So what we're going to look at here is genesis.ssz. This file is 2.5 megabytes, which is kind of big in some ways. In some ways it's also small, but this genesis.ssz is the Genesis beacon state for the network. If you're starting the network, the very first state is this Genesis state. I just downloaded it and I want to see what it looks like. Let's just open it in your word processor here. Oh, it is not very friendly. It's just binary data. And so you're not actually going to be able to get much out of this if you just download and try to open it normally. But here's where simpleserialize.com can come in. We can go to beacon state and we can open this up and deserialize. Let's see what it gives us. It's kind of a big object to deserialize here. Let's pop back over to this tab to get a little more room. And there you have it. This is the Genesis state in a more human readable format. Here you can actually see what is a Genesis state. Well, it has all of these different fields. Let's look at the Genesis time. We could, for instance, paste this in. This is in Unix time. Oh, we can see that the Genesis time is actually on the 29th. It was a little more than a week ago. And you can do even further investigation from here. That's just to, just to give you a taste. It's maybe there are better tools out there for really deep debugging, but just for a website to be able to do this is really nice. Let's keep going to our keygen website. So again, this is a website which can create new validator keys. I really don't recommend that you use this for any high value software. I recommend that you use the Ethereum Foundation developed web app. It's called the deposit interface. There's probably going to be more larger announcements about that, and maybe that will be incorporated into different teams clients. But this is just for education and for showing what Eth2 is all about. So let's just walk through what this looks like. So what we're going to do here is we're going to create a new master key. The way that we're going to do back up here of our mnemonic, and bingo, we created a new master public-private key. So the way that validator keys in Eth2 work is we have a standard that says that all keys should be derived from master keys. So there's this technique called hierarchical deterministic wallets is used across the crypto sphere. There's many different wallets use this. Basically, you have a master key, and this master key derives children. And so what you can do is you can back up your master key, and then your if you ever run into some data loss, you can restore your master key, and that master key can then regenerate all the children. So from here we can create any number of validator keys. Or validator indexes could be 0, it could be 1, 1,000, whatever. Each validator key is going to be a separate public-private key. And here we show the path, the hierarchical path that we use to create these keys. You'll notice here that there's actually two paths. There's the signing and withdrawal. Signing, otherwise known as the voting key, is used day to day in Eth2. And withdrawal key is usually kept offline. It's only ever used once. It's used to withdraw your funds from the system. We did this for security, so you can keep your withdrawal key offline. And maybe you could give your signing key to a staking pool, but the staking pool would not have access to withdrawal because they don't have the withdrawal key. In any case, we can export then these two keys. First, we need to type in a password. And why we're typing in a password here is we're typing in a password so that we can encrypt these private keys, and so that when they're stored on disk, it's not just a raw private key waiting to be hacked or scraped or what have you. It's going to be on disk. It's going to be encrypted. So, from our password, let's generate our keys. Takes a little bit. I encourage you, if anyone's interested, we have links up at the top here that show the relevant specs. One spec for deriving a private key from randomness, from entropy. One spec for the hierarchical key derivation, and one spec for how these keys are stored on disk. So if you notice, we got this big long string .zip, and so this big long string, if you look, it actually matches up with the public key to the validator. So that's what this kind of this big identifier is. Let's just take a peek into the signing key, or signing.json, just to see what this looks like. This file is something that you could load into a validator client. This has all the information you need to sign messages as a validator. Kind of the relevant parts here are, it shows you the path. This is validator number 1000. It shows you the public key. And then this line right here, the message, this is actually the encrypted private key. And all the rest of this informs the system of how to recreate that private key. Again, if you're interested, you can read through these different specs. And again, the withdrawal.json is the same thing but for the withdrawal key. So again, this tool, it's probably shouldn't be used in production, but again, it's just interesting to be able to create your own keys. You could use it to restore a key if you had a mnemonic. You can paste your mnemonic in here and restore. And let's get to the third thing, this ENR, decode ENR objects. So the Ethereum name records are used to, again, they're used to pass back and forth between peers to let peers figure out how to connect to other people. And again, I want to show how this relates to Eth2 testnets more practically. Let's go back to this Altona testnet directory. If we look at these bootstrap nodes are nodes that you connect to when your client first connects. It's the very first nodes that your client knows of. And from those nodes, you discover more and more peers. And if you look here, we've got a bunch of ENR colon blah. It's not really very readable. And so this is where this little utility comes into play. Let's just copy one of these, and we can paste it in, and decode it. And you can see inside here, we actually have all of these different pieces of data. So you can see this record is really informing us that we can connect to this computer at this IP and on this port. And with this public key, that's not it on this site, but this is actually pretty useful. I've used this just exactly as you see here. I was kind of curious, what are these? I can't read this. This is base 64, and this is kind of nice. So again, those are just the first three that we've come up with. We have a lot more. We have a lot of other different libraries that we've created, and so I think there's a lot more opportunity for more tooling, maybe more visualizations of things, and I hope that just showing you these things kind of gives you a taste of what's possible. Like, these apps, we kind of spun them up very quickly. I think this ENR app took an afternoon to make. I mean, we already had the library that can decode the ENR. It's just a matter of slurping it in the right way and spitting it out in a friendly way. And if you're a web developer, it should be pretty straightforward. And so, with those three demos out of the way, I wanted to do one last one. It's kind of a higher level here. I've got our Lodestar mono repo cloned down and everything built and configured to try to connect to the Altona testnet. And kind of dangerous doing a live demo, but we'll see how it works here. It works great. The idea is I want to show some really cool things that you can do when debugging, or when live debugging a JavaScript application, even using Node. So let's. Oh. So we're going to run node-inspect. This is kind of the magic right here. It's going to let us use an inspector to inspect the runtime. Lodestar beacon run with this node Genesis state. So we're going to be running our beacon node, and hopefully things will be good. I'm going to open up Chromium, and this is just off-the-shelf Chrome. I'm going to type in Chrome inspect. And here it just automatically found my running Lodestar. So I can inspect this, and immediately I get all the tools. If I'm a web developer, I get all of the tools that I get in the web. I have a running console that is connected to this node instance. I can look at all of the sorts of Lodestar as it's running. I can even CPU profile. And so, oh great, we're actually syncing Lodestar. Let me go ahead and run a CPU profile here. And this tooling is great. Thank you, Google or whoever did this. It's actually really invaluable for investigating errors and for finding bottlenecks and so forth. So let's just we're letting this run for just a little bit, just so we can pick up all this good stuff that's happening behind the scenes here. So it's good enough. All right, and here we have a flame chart, and this flame chart shows you roughly. It shows you what the program is working on at every given point in time. It's constantly looking at what code it's running, and so you can see visually what's taking a lot of time and what's not taking a lot of time. So just like at a glance here, we can see all these little tiny things happening, and there's this big, massive chunk. Like, what is this big chunk that's happening here? Well, it looks like it's our state transition, and it is rotating epochs. Okay, so what is rotating epochs? What does that mean? Okay, well, we can click on this and go right to the source code. That's taking a lot of time. We can, let's see, we can dig in even deeper, and we can see, okay, actually the thing that's taking the most time in rotate epochs is reset proposers. We can see it's computing the proposer index over and over for several times. And so maybe this would be an opportunity then to investigate this function and see if we're doing anything stupid or slow, something that can be updated. And kind of incrementally, in a kind of a live way, we can be making this better. It's pretty amazing. I think this is pretty amazing. I just recently learned about this, and it's already changed the way that we are developing, because we can really quickly see what's taking a long time and what's not. And I really encourage anyone who's a web developer running node programs to try this kind of tooling out. And with that, I believe I'm done. Let me see. We have questions. I really encourage anyone who's interested I peaked, to join us to see what we're up to. We're on GitHub,
That's awesome.
and we have an open Discord channel. We're on there all the time, talking about what we're working on, answering people's questions if they come on. And we're on Twitter at ChainSafe5th.
Yeah. Oh my gosh.
Yeah,
I'm just like blown away by the last thing that you just showed us.
the flame chart is so
Oh,
cool.
yes. Awesome.
That was really cool.
Yeah.
So I'm just gonna repeat the website right now. It's lodestar.chainsafe.io, correct?
That's right.
Where the web tools that you can get access and like try it out. So there are like 3 beautiful projects, web tools that are like you are able to try it out with this website. So it's lodestar.chainsafe.io. So we're open for questions right now, like open the floor to like anyone who has questions. So you can drop us the question right now. And CC has a few questions before.
Oh, bit, uh, let everybody ask first, and then I'll ask my question later.
So we've got like several like people joining this call right now, and I wonder if people who are in this call,
Who have questions?
maybe Summer or
Yeah. Can you?
yeah, can you speak a little louder?
Yeah.
Okay. My question is, when is this client is going to be online? I mean, when is what's the timeline for this project? And
Right.
this is the first. And the second question is, have these projects been audited by a security firm? That's all.
Okay, good questions. Okay, yeah, the first question, timeline. So, I would say that our client is a little bit further behind than some of the others. If you've been following Eth2 development news, there's currently 4 clients who are pretty robust on this Altona testnet. We're not one of those 4. Those 4 are Lighthouse, Prism, Teku, and Nimbus. We're still working through some of the kind of late stage kinks in the software, and for a timeline, we're really hoping to have our client ready, at least the minimal viable client ready for this public testnet, because we think that having that client ready by the time we'll be able to, by participating, it's great because it gets other people involved in the software, and it really helps the whole ecosystem. So I would say within a month or so, we'll probably have ironed out some of those kinks. I'd say maybe in a few releases. We usually release every other week. But if you want more granular updates, definitely come to our Discord, and they can give you more detailed information. Second question about the security audit. So we've done one security audit of a few of our packages. There's a lot of them here, and we did it a few months ago, and so not all of them were ready. We do plan on doing another round of security audits when they're ready. So the ones that have been audited as of now are this persistent Merkle tree, and BLS HDKey, BLS Keygen, and BLS Key Store. Everything else is on the audit pin at the moment. But again, that's we have that's something that we're going to be doing for sure. It's definitely very important to have some security professionals look at this before if it's used for any significant amount of value.
Got it. Thanks.
Any more questions from people who are in this call right now?
Summer? Bingo?
这个是谁？
Bingo.
Hi, it was a great talk.
Yeah, go ahead.
What is in your opinion, what is the advantage and disadvantage compared with other implementation of VChain?
So the advantages and disadvantages. So maybe I guess I could start with some of the disadvantages and then move to the advantages. Some of the disadvantages compared to some of the other clients, JavaScript, you don't have as fine of control over the code that you're writing. You're writing it at a higher level, and this code is running inside the JavaScript VM. So kind of there's some performance disadvantages. Say in a language like Rust or Go, you're much closer to the middle, and you can write algorithms that take full advantage of the computer. You can hook into some like raw assembly code, hand optimized assembly code. And while we could use something like that in Node, if we want to have code that can run in the browser, in Node and the browser, we can't take, we don't have the same, we just don't have the same flexibility in terms of how we're using the machine. I'd say that's probably the biggest disadvantage. Maybe another disadvantage is just the JavaScript has a less flexible way of running things in multiple threads. There's not really shared memory across threads in JavaScript, and usually the way that you write JavaScript is in a single-threaded way. And so if you're really heavy on if you have like a lot of computationally intensive things, you're not really able to offload those as easily. And so right now, all of Lodestar is single-threaded, with the exception of a few kind of built-in networking pieces. But the advantages, it's kind of the advantages of having a dynamic language. I think debugging is a lot easier. Kind of the whole kind of cycle of development can have a faster feedback loop between you writing the code, testing the code, trying it out. You can paste code into a REPL and just very easily can quickly be testing it and playing around with how it works. And maybe another advantage is the fact that there's a lot of developers who know TypeScript, and there's probably a lot fewer who know things like Rust or things like Vim. And so there's probably like a mindshare advantage there. I think that's about it. The big ones.
I see. Thank you for your answer.
他在问什么？
Disadvantage of Lodestar.
Any more questions? Maybe
If not, I have one.
CC has a bunch of questions.
No, just
There
one.
you go. There you go. You have it.
You mentioned assembly script. I'm very curious because that's new to me, and I'd like to hear you share it more. Should we try it now, or I mean like should we? I mean not literally now, but just
Do you mean like does he recommend you?
yeah to
Oh yeah.
yeah
Yeah, that's a great question. Assembly script. So right now we have one library written in assembly script. We have a SHA 256 written in assembly script, and I can just quickly show you here assembly. Kind of what it looks like. It's all just one file. It looks a lot like TypeScript. And some of the semantics are a little different, so you can't get too carried away thinking it is just TypeScript. But I think I do recommend it. You can get it's very close to the metal of WASM, whatever that means. Being close to the metal of that, but you can basically write pretty small WASM blobs, which can be very important. So, for instance, let me explain why it's really important. When you're loading in a WASM blob into a browser or a node, you have to load that module asynchronously. So load it and then await its eventual loading and instantiation. And so you're not able to run. You're not able to run WebAssembly code synchronously. Well, you have to have an asynchronous initialization period. Except if your WebAssembly module, the compiled module, is less than 5 kilobytes. And so that's what we've done with this assembly, the SHA-256. It's a very tiny WebAssembly binary that we can load synchronously, and so we can avoid this asynchronous loading. And the reason we can do this is because we wrote this by hand, or we wrote this in a way that it doesn't use any of the assembly script runtime. It is just SHA-256, pretty standard. And yeah, now we're able to use it with the exact same function signatures and everything as your normal off-the-shelf SHA-256, but with very dependable results performance-wise across node or across the browser.
Oh, cool. So, okay, it's the purpose of the AS sharp 256 is to load it synchronously to the browser, or just to
yeah, so I can give you an example of just the asynchronous loading. It's kind of a pain, and so our BLS. Let's see. Our BLS library is actually, it uses a WASM compiled C++ library, and it's a lot larger. And so whenever we use it, we have to first run an init function, wait for the init to finish, and then we can start using the BLS operations. And so that kind of limits the ways that you can use it. And with assemblies, with this SHA-256, we don't have to do any kind of a waiting or anything. We just use it normally. There's no fancy waiting or no strangeness to it.
Oh, I see. So that's why we see the loading screen on the BLS website.
Oh, the reason that we see that is because the BLS standard uses script, the STRYPT, to derive the secret from the password. So script like the proof of work in Litecoin, the script, it's supposed to take a long time. So it's hard to brute force. It's hard to brute force to your private key from the password because it takes a long time to test each password.
I see. Cool.
DLS in it, and then you can do everything.
Oh, nice. So these tests, they are all synchronous call.
These are all synchronous, but you have to wait this asynchronous initialization. And this is
Oh,
kind of a
okay.
WASM. This is kind of what you have to do right now for WASM, using WASM. This initialization is actually loading the WASM into your JavaScript runtime and initializing it. Then it's ready, and then you can use it.
Oh, I see. Oh, what's that?
So it's kind of a hiccup to using WASM everywhere, but it's definitely like also we would not be able to run our client without this BLS library because it's pretty dang fast compared to like a native JavaScript implementation of BLS.
Yeah, I can imagine that. Yeah. Yeah, I'm considering rewrite some of my applications.
What have you been working on? You want to talk about
Previously,
So I'm asking what CC has been working on.
previously,
Yeah.
was on semaphore authentication.
So
And
when you met Cayman, you were working on something else. Do you want to talk about
so, yeah.
Because you're like changing all the time.
Yeah, I'm changing all the time. Yeah, what do you mean?
The project that you introduced to Cayman when you were at ECC in Paris
Yeah,
is
it's semaphore authentication. So it's using zero knowledge proof to that you log in the website, but the website just know you are a registered user, but the website doesn't know who you are, who exactly user you are. And
right now you
and
have another project.
yeah, right now I have another project, and the semaphore authentication has a lot of JavaScript code, and some of it is using some WebAssembly optimized code. That's it's not written by me, but yeah, I'm like very excited to try it out in somewhere. Yeah, assembly script. Yeah.
The stuff we are working on.
Stuff I'm working on is more. It's more. It's optimistic raw, but it's more about travel and smart contract and less JavaScript.
How many people are in the Lodestar team?
So right now we have 4, about to be five members.
Yeah.
Oh, 5
So if
So, yeah, 3 full time and 2 part times.
So if people are interested in like contributing, should they like how would they?
GitHub link.
So just go to the GitHub link.
Yes, I would say definitely join our Discord. That's where you can talk to a real person in a chat room. Our team, we're basically always active there, kind of discussing the latest status of things. People come and ask us questions. We're very happy to bring them on. And in fact, like it's funny, the entire Lodestar team right now all came from outside contributors. So we all basically just joined this team because it was like, oh, this is cool. Like we saw it on GitHub, we started contributing, talking on Discord, and like just through this kind of process, we've all started doing this either part-time or full-time. And so just it's kind of in our DNA at this point as a team is to just, we're doing things in this very open kind of environment, very open kind of way.
That's very cool. That's a dream of every repository owner.
Yeah.
Absolutely.
Yeah.
Keep attracting those contributors.
Yeah.
Cayman is an open source advocate. So we're gonna
Yeah.
So I think we are going to wrap up right now. So I encourage everyone who wants like further information and like chat with Cayman maybe. So join this Discord or like take a look at the GitHub repo. So our next meetup is in August.
Wow.
I hope. I hope there's nothing more in between. Because like I have like a bunch of other online events coming up.
Okay.
And the Radical Exchange Taipei also has like a podcast interview thing this month. So I don't know why I'm saying this, but because like I'm like managing the Twitter accounts of Taipei Ethereum and Radical Exchange Taipei, so I would love you to follow us. Yeah, so thanks very much, Cayman, for your time. We'll be seeing you soon.
Yeah.
Bye bye, everyone.
Thank you for having me.
Thank you, Cayman. Thank you, everyone.